Today we're going to look at annuities. So an annuity is a regular payment. Common forms are for things like superannuation, where a payment gets made each payday, each fortnight or each month, but it is a regular payment. In particular, what we're looking at today is we're looking at how to calculate the future value. So the words there should give you a bit of a hint as to what we're finding. We're finding the amount that a payment will be worth in the future at the end date. So our question here is, Rebecca invests $3,000 at the end of each year over 5 years at 6.5% interest. How much will she get back at the end of the 5 years? So the annuity, it's a fixed sum of money paid to an account with interest compounding at the end of each period. So that end point is important, and you'll see why when we work through this question. The future value is the total value of all contributions and compound interest at the end of the period when the final payment is made. What's important here is that no interest is paid on that final payment because it's paid at the end. Now, so what we're going to use today, we're going to use the compound interest formula of A equals P outside of 1 plus R to the power of N. So here, A will be the value of the investment, the total value that this particular payment is worth at the end of the period. P is the value of the annuity. So how much is being paid? R is the percentage per period, and N is the number of periods. So we'll have a look at what each of those is worth in a moment. Now, let's have a look at what happens here. If Rebecca makes $3,000 investment at the end of each year, over 5 years at 6.5% interest, how much will she get back at the end of the 5 years? Her first payment isn't made until the end of the first year. Her second payment isn't made till the end of the second year, and her third payment isn't made until the end of the third year, etc. So how does that impact how long it actually stays in there for? So her first payment is there for only 4 years, not the expected 5 that you might have originally been considering. Her second payment is there for 3 years. Her third payment, because it's paid at the end of the third year, is only there for 2 years. Her fourth payment is only there for 1. And her fifth payment isn't even there for a year. So let's have a look at that. So payment 1, she's going to have that for $3,000 invested for 4 years. So that will give us $3,000, which is our P, times 1.065 to the power of 4. Now your 1.065 is your 1 plus your R. So that's 1 plus 6.5% or 1 plus 0.065 as a decimal. And the 4 is because it will be there for 4 years. So her first payment at the end of the 5 years will be equal to $3,859.40. Her second payment will be invested for 3 years, as we looked at. So that gives us 3,000 times by 1.065 to the power of 3. So when we pop that into the calculator, we get $3,623.85. So the second payment should be less than the first because it's only been there for 3 years, not 4. Our third payment of $3,000 is invested for 2 years. So our future value of the third payment is 3,000 times 1.065 to the power of 2, which gives us $3,402.68. And then our fourth payment, which is only there for 1 year, we will get 3,000 times 1.065 to the power of 1, giving us $3,195. And then we have our fifth payment. Now, fifth payment doesn't actually stay in there for a full year. So our total value at the end of 5 years is going to be $17,080.93. So Rebecca would get $17,080.93. I hope you found this video helpful.